For the past 2 years, the frontier of AI development focused almost entirely on single-turn reasoning, but raw text generation has finally reached a plateau. Today, the new engineering challenge is achieving reliable, long-horizon coordination. Anthropic's Claude Opus 4.8, released in May 2026, was specifically engineered to address this. It targets the specific economics of autonomy, sustaining multi-step tasks without degrading logic or overspending on compute. This bar chart tracks the superagent benchmark. Prior models struggled with consistency, but Opus 4.8 hit 100% completion end-to-end, outperforming GPT 5.5 at identical cost. Achieving this without a price premium suggests the leap is driven by structural efficiency, not just higher parameter counts. This efficiency is built on two technical shifts. First, Opus 4.8 gives developers direct control over compute scaling. Second, it addresses long-term memory costs by preserving prompt caches even when instructions are modified mid-task. These updates are supported by a significant jump in raw logic. Opus 4.8 scores 96.7% on the USAMO 2026 math benchmark, the largest single-cycle leap in the history of the Opus line. These gains in math and logic provide the foundation for a model designed to coordinate multi-step workloads. This dashboard displays Opus 4.8's real-world coding performance. It reaches 88.6% on SWE Bench Verified and 69.2% on SWE Bench Pro. It also hits 84% on online mind-to-web, setting a new benchmark for browser-based task completion. These scores stem from structural improvements in how the model handles JSON payloads and function calling. While previous models often produced verbose tool calls that introduced errors, Opus 4.8 generates lean, precise instructions. Anthropic also revised the model's internal judgment. Opus 4.8 is 4 times less likely than its predecessor to overlook flaws during a code review. Rather than executing every command as written, the model now flags logical uncertainties and pushes back on unsound plans before it begins execution. According to the alignment team, the model shows higher rates of supporting user autonomy while reducing instances of misaligned behavior. These high-level benchmarks are the result of catching logical flaws early and reducing unnecessary verbosity in the model's output loops. Deploying autonomous systems introduces a strict financial problem, paying for maximum reasoning power even when a task only requires simple data parsing. This interface shows the standard $5 input price, plus a new effort slider. Users can adjust compute from low to max. Defaulting to high, max uses more cycles for better results. Fast mode is also updated, 3 times cheaper than before at $10. This tiered system enables a specific architectural strategy. Engineers route high-volume data parsing through fast mode, reserving max effort for difficult logical extractions. Precise control over compute overhead changes the financial math for companies deploying agents at scale. By enabling compute routing at the API level, Anthropic addresses the historical bottleneck where token costs for multi-step systems eventually exceeded their utility. Long-horizon workflows face another hurdle. In earlier systems, updating a system prompt mid-task would break the prompt cache. This forced the system to reload the entire context, creating latency and increasing costs for every subsequent step. This structural update to the Messages API accepts system entries directly inside the Messages array. Developers can now alter an agent's instructions on the fly without breaking the existing prompt cache. This structural update resulted in a 61% reduction in token costs for document-heavy workflows, according to Databricks. It also improves performance by ensuring the model maintains its full context across long sessions. Persistent context allows for better citation precision and more consistent technical execution during extended interactions. Persistent caching makes multi-step agentic loops economically feasible for enterprise-scale work. Precise tool calling, effort control, and unbroken cache loops allow for the creation of a massive, synchronized swarm of agents. This capability is the focus of Claude Code, a new research preview for dynamic workflows. A central masternode assesses a project, spawning hundreds of parallel sub-agents to handle individual components simultaneously within a single session. After each subagent performs a self-verification check, the system reconsolidates the verified data into a single output to merge the changes. This workflow enables code-based scale migrations across hundreds of thousands of lines of code without manual human oversight. These features are currently being rolled out for Enterprise, Team, and Max plans. The success of this parallel approach is also visible in knowledge work. Opus 4.8 is the first model to break the 10% all-pass standard on the legal agent benchmark. Opus 4.8 is no longer limited to isolated tasks. It can now manage complex technical operations from start to finish. This blueprint represents a shift in how AI models are structured to handle labor. The model establishes a new baseline for the industry, defined by high judgment fidelity, adjustable compute effort, and mid-task cache stability. By addressing the financial and technical barriers to multi-step logic, Anthropic has created a platform for building scalable, autonomous applications. However, Opus 4.8 is only the foundational layer for the next stage of development. Anthropic is already testing Mythos-class models under Project Glasswing, currently in limited preview for advanced cybersecurity tasks. As models move toward true autonomy, the developer's role is changing. The primary task is no longer writing the right prompt, but architecting the right system.